All right, chemistry, we're on our second lesson dealing with solutions. This one deals with solution stoichiometry, and it's day 55. And you have the same cover sheet that you had before. On this cover sheet, by the way, this should change to a 1, that 2. So it should be M1, V1. And in later lessons, it's been changed, okay? So M1, V1 equals M2, V2. And just make that correction. Okay, so let's go ahead. We're going to do the A problems together here. So what is the molarity? You're looking for molarity. So molarity is moles of solute. That's what you're mixing in. That's the lemonade powder. In this case, it's not lemonade powder. It's salt. It's table salt, same kind you use at home. So it's moles of table salt over liters of solution. Okay, and let's just remember that what solution means. It's the NaCl, that's the solute, the smaller amount, plus what it's being dissolved into, and that's virtually always going to be water. I'm going to say always going to be water, unless there's really some exception. Okay, so that's the solution. All right. Okay, so you need to, this is your target. It's what you're trying to hit. You're trying to hit moles of NaCl on the top, liters of solution on the bottom. You're given two numbers to work with. You're given a mass and a volume. And you see that you want a volume on the bottom here. So the way we're going to set that up, you're going to come way over here, and we're going to say 5.4 grams NaCl over the liters. And it says liters of solution. Okay, so that's what we're starting with. That's what we want to end with. If you look at the bottom, you have liters of solution and liters of solution. So you don't need to make any change to the bottom. The bottom is exactly what you want it to be. Up here you have grams, and over here you have moles. So you're going to need to make a molar mass conversion. Moles is moles, number of particles. Grams is mass, what the mass is. So we need a conversion equivalency here for NaCl. And you do this from your periodic table. 1 Na plus 1 Cl. There it is. So you only need one box. You don't have to draw the boxes. But we need grams to cancel out, so we're going to put this one on the bottom. Grams of NaCl, grams of NaCl. So now we have moles of NaCl on the top. We already had liters of solution on the bottom. So we're done with the setup. We now just need to do the math. Okay, so 5.4 divided by 0.24 divided by 58.44, and that gives you 0.39. And the way you should finally write that, although I would not mark it wrong on a test if you didn't, is its molarity, it's capital M. Okay, so that's that. Okay, move on to A. You want to create 500 milliliters of 1.2 molar sodium hydroxide solution. How many grams of NaOH would be required? That's a very practical lab problem that you might have to do. You'd have to figure out how many grams you need if you want 500 milliliters and you want that concentration, okay? All right, so it's asking for grams. We're going to put that way over here. Okay, now we have 500 milliliters, that's a unit of measure. We have molar, that's moles of NaOH over liters of solution. So we have a top and a bottom, so we can't just put this number over this number. Can't just do that. So what we're going to do is we're going to take the 1.2 molar, that's moles, solution is the NaOH plus the water together, okay? So we're going to start with this. And we're going to say, okay, we need to get from moles of NaOH to grams of NaOH. Okay, anytime you hear moles to grams, grams to moles, it's a molar mass conversion. Okay, and NaOH is a pretty easy one. Go to your periodic table, add a sodium, add an oxygen, add a hydrogen together, and you get exactly 40. So that will get us from moles to grams. Which one goes on the top, which one goes on the bottom? You need to get rid of moles, have grams show up. So you need moles on the bottom in this one. Moles NaOH cancels. So now you've got grams of NaOH up there. But you got liters of solution down here. You don't want that, okay? You want it to disappear. You want nothing. You could say you want a 1 down there, and that's fine to say it that way. That's technically what it is. It's a 1. It's this over 1. So first of all, we have a milliliter number to work with. So first, let's convert this liters to milliliters. And it's of solution. It's true of any substance. 1 liter equals 1,000 milliliters. But okay, so liters of solution, liters of solution. Now we have milliliters of solution on the bottom, and I didn't leave myself quite enough space here. So I'm just going to erase this. I'm just going to put an equal sign right there, and we'll write the answer up here. Okay, now you want to get rid of the milliliters because you have nothing on the bottom. So if you put milliliters on the top, it's going to cancel. You'll have no units on the bottom, and we get it from this. So it's times 500 milliliters of solution. And you don't need to put anything down on the bottom. If you want to, though, you can put a 1. Okay, if you don't like leaving that blank. Okay, so it's milliliters of solution, milliliters of solution. So now you see all the units on the bottom have canceled, so we don't have anything on the bottom over here, okay? So it's 1.2 times 40 times 500 divided by 1,000. And if you come and write the answer down here, that gives us an answer of 24 grams of NaOH. That's how many grams you'd have to measure out on the scale to get 500 milliliters of a 1.2 molar solution. Okay, so that takes care of that. All right, we're going on to 2C. Okay, so you want to, B and C. No, B and C are exactly the same as A. So I have you, because this is kind of an important problem, it's a very practical problem to do in the lab, I'm going to have you do it twice. So you do it 2 more times. So we're going on to 3A. What is the molality? Okay, that's small m of 3.7 grams of lithium hydroxide in 356 grams of water. So come over here and define molality. Again, all of these you get off the front page. Molality, it's moles of solute over kilograms of solvent. It's about the only time in chemistry you'll see kilograms. Everything in chemistry is generally grams. Physics deals with kilograms more often, but there it is, kilograms of solvent. Now the solvent is the water, it's not the solution. Okay, so we're going to come over here and write that. And the solute is what you're dissolving in, that's your lemonade powder. In this case it's LiOH, lithium hydroxide, over kilograms. And the solvent is H2O. It's not solution, it's H2O. It's what's doing the dissolving of the LiOH. Okay, so over here you have 3.7 grams. And it's in that much water, okay? And that's the water down there. So we're going to put the 3.7 on the top. And the water on the bottom. Okay, so remember in these problems, you do 2 separate problems. You take care of the top first, then you take care of the bottom. You could do it in the reverse order, but let's just stick with that. So we need to get from grams to moles of LiOH. So you're going to have the molar mass of LiOH because you got to go from grams to moles, any of that. So we're going to go 1 mole. So molar mass of LiOH, you take 1 lithium, 6.94. You take a hydrogen up above there, which is 1.01, and you take an oxygen, which is 16. You add those together, and you get 23.95. Okay, so now we can do the molar mass conversion. We need to get rid of grams. We need that to cancel out, so we're putting this on the bottom. Okay, so we've taken care of the top, moles LiOH, moles LiOH. Now we need to get from grams of H2O to kilograms. So that's one of your three standard conversions. The three of them are 1,000 grams equals 1 kilogram, 1,000 milliliters equals 1 liter, and 1 milliliter of water, only of water, equals 1 gram of water. Those are your three basic conversions. So what we need is the grams to kilograms. And that's true of any substance, but we're interested in H2O, so we're going to put H2O there. Grams of H2O, grams of H2O, so we have liters of H2O on the... I'm sorry, I put liters. Wrong, it's kilograms. 1,000 grams equals 1 kilogram. Okay, so now we got kilograms, so it's 3.7 times 1,000 divided by 356 divided by 23.95. And that gives us 0.43 moles LiOH per kilograms, or the way we should write it is 0.43 small m, molal. That's what it's asking for. Okay, 4a, what is the mole fraction, that's chi, mole fraction of 25 grams of KCl in 332.4 grams of H2O? So the solute is potassium chloride. You're dissolving that, you're stirring that into water, and that's your solvent. So the solution is those two together. But what we need to do is this. Go ahead and write the formula for mole fraction, and it's moles of solute, the KCl in this case, what's being dissolved, over the moles of solute, all solutes actually, but there's only one here, plus moles of solvent. That's the water, what's doing the dissolving. Okay, so we're just going to plug that in. You don't multiply by 100% or anything like that. So you have this. So first of all, you have to do molar mass conversions because you're given grams. So we're going to go ahead and do that right here. And it's 74.55 grams of KCl for every mole. We need to get it into moles. So we're going to put moles of KCl on the top and grams of KCl on the bottom. Okay, and that's going to be 25.2 divided by 74.55. And that gives us 0.34 moles. Okay, my conversion for water, I'm going to do it up here because I need the space. So again, you might want to do these on line paper. Sometimes these take more space. You may look like you have a lot of space, but you may not have as much as you think. So 332.4 grams. Molar mass is 18.02 grams per mole. We need the moles on top. And we get 18.4. And some of you were asking me about how many decimals or sig figs. Don't worry about that. We really don't worry about that much anymore. We may occasionally talk about it just to refresh our memory of what it is. Okay, so now we're going to plug it into this. We have this for KCl, we have this for H2O. So moles of solute is going to be, I'll draw a line here, block it off here so you can see it a little cleanly, equals 0. That's that number right there. On the bottom, it's going to be that number again. Plus the moles of water. And I put grams here. That's a mistake. Maybe you caught that. We need to get to moles. We started with grams. We need to get to moles. So it's 18.4 moles. Okay. And I'll show you how to do this on a calculator when you have this plus sign on the bottom. So what I'm going to do is I'm going to put 0.34 divided by parenthesis 0.34 plus 18 point, and I put O there, I don't know why. Pencil's faster than my brain. Okay, 18.4 close parentheses. So PEMDAS says you're going to do the parentheses first and then do the division. And when you do that, you get 0.018, okay? So that's chi equals 0.018. It's dimensionless. It has no units of measure because moles cancels out, okay? It's just called a mole fraction even though it's a decimal number. Okay, 5A. This one's a challenge. Okay. And I gave you a B and a C for this as well. All right. So, seawater has a density of 1.027 grams per milliliter. So that's mass over volume. That's what density is. How much mass, how much matter you're stuffing in to a certain amount of volume, a certain amount of space. That's what grams per milliliters means. Okay, and is comprised mainly of sodium chloride, so it's basically NaCl and water. What is the molarity of a solution that is 3.5 mass percent sodium chloride? So we're looking for molarity. So we're going to come over here and we're going to come up with moles of NaCl over liters of solution, which is the NaCl plus the water together. Okay, let's go through and pick this apart. Seawater has a density of 1.027 grams per milliliter. Now I'm going to write up here because I'm not going to do this problem, but you don't want to necessarily write up here. You can write over in the margin. Okay, what does that mean? It means 1.027 grams for every 1 milliliter. Now, grams of what? Well, seawater has a density. It's the seawater. That's the solution. That's the salt and the water together. So I can write solution here and solution here. So what does that look like to you? That looks like a conversion factor. You could write another one if you're so inclined. 1 milliliter of the solution, the seawater, the salt and the water together over 1.027 grams of solution. So you have two conversion factors, so that'll come in handy later on in the problem. Now, is mainly comprised of sodium chloride. So it's solute, sodium chloride, solvent, water. What is the molarity? We read that. Now, here is the other one that you'll never figure this out unless you're taught. So I'm going to teach it to you. What do you do with mass percent? Here's what you do, and I'm going to want you to write down this rule. I'm going to write it down here because I'm not going to do this problem, but you should write it somewhere else. Okay, so let me get on screen here. When you have a mass percent, you get to choose how many grams of solution you want to use. That's your choice. You get to choose it. You will always choose 100 grams. Why? Because it's a nice round number. It's a relatively small number. It's not like 1,000 or 1,000,000. So think about it. What is 3.5 mass percent? It means grams of solute, NaCl, over grams of solution times 100%. So let me give you some examples of mass percent. 3.5 grams over 100 grams of solution. 3.5 grams of NaCl over 100 grams of solution. How about 35 grams of NaCl over 1,000 grams of solution? That would be 3.5%. How about 350 grams of NaCl over 10,000 grams of solution? That would be 3.5%. So you're getting the idea. There's an infinite number of possible combinations of grams of solute over grams of solution that will give you 3.5 mass percent. So you get to choose, and what you're going to always choose is the 100. So what that means is over here, you're going to start with, way over here, 3.5 grams of NaCl over 100 grams of solution. That's the NaCl and the water together. So now you actually have some grams to work with here, okay? So that's the way mass percent works. You just have to kind of learn that rule. Nobody ever figures that one out on their own, or rarely does anybody. So now you know it. Okay, so here we go. We need to get from grams of NaCl to moles of NaCl. That's the molar mass conversion. Let's write it out. Okay, so what we're doing is we're dealing with the top first, grams of NaCl to moles of NaCl, so we need that molar mass, so it's going to be this. So grams of NaCl cancels and cancels, so now all you have on the top is moles of NaCl. That's what you want at the end. You're done with that. Now we need to get from grams of solution to liters of solution. This is a unit of mass. This is a unit of volume. Okay, so how do we do that? Well, the good news is we have a conversion factor that we figured out up here, that we can get the grams to cancel out and get milliliters of solution. That's getting us towards liters, right? So which one of these do we choose? Well, we have grams of solution on the bottom here, on the top here, so we want to choose this one. So that's what I meant. That's really a conversion factor. That density converts you from grams to milliliters. Okay, grams of solution, grams of solution. So now we have milliliters of solution. We need one more conversion. We need our standard milliliters to liters. So 1,000 milliliters, this is true of anything. 1,000 milliliters of solution over 1 liter of solution. Milliliters cancels with milliliters. So now we have moles NaCl on the top. We have liters of solution on the bottom. So now we're ready to do our calculation. Okay, and that gives us 0.615 moles of NaCl per liter, but that's called molarity. So we write it like that, and that's our final answer. Okay, you do C. You do B and C. I wrote all this down in B. You shouldn't have done that. But that's the key, is to remember how to deal with mass percent. Okay, I'm going to check out on this video.